Good afternoon, students. Today's class means this class is a continuation to the last class. During the explanation of the IEEE 488 bus, the last video class was terminated. So here the IEEE 488 bus is used for means which you can see on the screen. So I'm going to send this document to you in the WhatsApp group. So here this particular IEEE 488 bus is going to be used for communicating the devices using the parallel communication. As we know that we have the serial as well as the parallel communication. The IEEE 488 bus is also named with different names, which is the GPIB and the HPIB, which you can see in the document. And here this particular this particular IEEE 488 bus is a 24 pin connector. So using this particular 24 pin connector, that is a IEEE 488 bus, what we can do is we can interface a maximum of 15 devices. We can interface a maximum of 15 devices. Okay. So when you are trying to interface the 15 devices, only one device is able to send the information, and the rest of the devices are going to receive the information. Means at a time, multiple devices are unable to send the information. Only one device is allowed to send the information, and the rest of the devices should be in the disabled mode. Disabled mode in the sense they should be the slaves. They should act as the slaves or the receivers. Okay now. But if you are going through the explanation of the IEEE 488 bus, you will come across two terminologies called as a talker and a listener. Talker and listener. Talker is nothing but the transmitter or master. Listener is nothing but the slave or the receiver, receiver. So in case of the IEEE 488 bus, the terminology is a transmitter is called as a talker and the receivers are called as a listeners. Okay now. So using this particular bus, we can send the data with a rate of 1 megabyte per second. With a rate of 1 megabyte per second. Okay now. So here, as I said, it is a parallel bus now. The maximum length of this particular bus is going to be the 20 meters length, and there is a practical scenario given that the devices which are trying to communicate, they should have a distance of 2 meters, but it is not going to be there. If it is not going to be there, so let us see the 24 pins, how they are going to be used, which I am scrolling on the screen. So if you see this one, the total 24 lines are grouped into 4 categories. One group is the data lines, means here 8 out of 24, only the 8 lines are acting as a data lines. Only the 8 lines are acting as a data lines, and out of 24, 8 lines are acting as a data lines. And other group is a handshaking signals, means these three signals which are named as a DAV, data valid, not ready for data, not data accepted. These signals are acting as a handshaking signals for the communication in order to exchange the data between the devices. And after that, in order to take care of the bus communication, means control what the terminating the communication and stopping the communication, cross checking whether the communication is going smoothly or not. To do all those things, in order to manage all those things, other group of signals are called as a bus management signals, which are named as a end or identify, interface clear, service request, attention, remote enable, and all those things. And these are the 3 categories now. One is the data lines, another one is the handshaking signals, and another case is a bus management signal. The 4th category is a ground lines. Ground lines means the out of 24 lines, 8 lines are acting as a ground lines. Why we are supposed to have the 8 ground lines means when you are trying to trying to interface the multiple devices using the common bus. As we know that if you want to exchange the data between the 2 devices, we should have the common ground. Okay now, we should have the common ground. But the problem is when you are taking ideal characteristics, forget about the rest thing. Ideal characteristics of the ground is nothing but 0 volts, but when you are taking a particular practical device, the ground is not going to be the 0 volts. It is having some millivolts range voltage. So just like that, other devices are also having the grounds. They are also having a minimum voltage which is in the millivolts range, and the micro, some of the devices are giving the microvolts range. So these voltage difference, when we are interfacing the devices using one communication path, at that time we are supposed to have the common grounds. And when you are connecting them to the common ground, as they are having the what we say, the different ground voltages, those ground voltages are going to be takes the responsibility to introduce the noise into the communication path. to introduce the noise into the communication path. When we are having the multiple devices are communicating, when the multiple devices are communicating, they are having the different grounds, and the ground voltages with respect to the each device is going to be varying. And when you are trying to communicate them on one ground lines, common ground lines, obviously there is a voltage difference, and that ground voltage difference is going to be affects the actual communication. Means the data which is going to be transferred from one device is going to be other device is going to be varying. And also there is a chance of the receiver is going to be get affected because of this ground voltages, ground difference voltages. So that's why we are having the multiple ground lines. And also to protect the receivers from the ground voltage differences, what we are supposed to do means we are supposed to use the I think on the online the material which I sent you, in that we are having we are supposed to use the Smith triggers along with the diodes. Smith trigger along with the diodes. Okay, now the Smith trigger along with the diodes are going to take the responsibility to bypass the voltage differences with respect to the ground to the actual ground. So to avoid the noise involvement within the communication, we are going to have the Smith. We are going to use the Smith trigger along with the diodes. They are taking the responsibility to what ground them properly to the actual ground. Okay, now so this is what we are having. Means because of this ground voltage differences, we are using the multiple ground lines in this particular bus path. Remember that when the devices are communicating using the common bus, when the devices are communicating using the common bus, at that time the devices should have the common grounds. But when you are going to use the common grounds among the devices, there is a voltage difference between the one device ground to another device ground. Those voltage differences are going to be takes the responsibility to involve to create the noise in the communication path. In simple ways, to create the noise in the communication path. So that's why we are this particular IEEE 488 bus is trying to provide the 8 different ground lines, and these noises, whatever the noise inducing properties are there, those are going to be bypassed to the actual ground as a common ground with the help of the Smith trigger and the diode signals, which are the Smith trigger and the diode is going to be used for nullifying this voltage differences. And also we know that the IEEE 488 bus is following the TTL logic family, and this particular TTL logic family is nothing but it is sending the information in the zeros and ones format. The TTL logic family strength is a we have seen that characteristics values in the last class, so I'm not going to repeat them. Okay, so now IEEE 488 bus is a 24-pin connector which is having the those 24 lines are grouped into 4 categories. One is the data lines, handshake lines, bus management lines, and the ground lines. You can see everything on the screen, so please take care of that. Okay, so here we are having the data lines now. So in order to we are having the data lines now, only 8 data lines are there for communication. So that's why we can send the information in the 8-bit format. Means in the byte format we can send the information. So if you want to see that how exactly the devices are going to be communicate using the IEEE 488 bus, I'm having one image. Wait a minute, I'll show the image over here. Yeah, this is the image. Okay, now so using this image, if you see this image, wait, if you see this image, device is not responding. If you see this one on the screen, so we are having a 24 lines. So we are not showing the ground lines actually. These are the different devices which are participating in the communication. So depending on the device, for example, I am taking the printer. Do you think that the printer is able to send the information if it is only meant for printing the data, not for the scanner? So if that is the case, it is always acting as a listener. Okay, now if you see this one, as I said, at a time only one device is going to become the master and the rest of the devices are the slaves. So some of the depending on the type of the device, some devices are always acting as a master, some devices are some devices are acting as a master as well as a slaves, some devices are always acting as a slaves. So one of the example is a printer. Okay, now printer is always prints the information and it is not going to send the information to the what is that master. And other cases going to be other digital devices. Some of the devices are the talkers, that is nothing but the sender, and they may act as a receiver. Some of the devices only the talker, some of the devices only the listeners, and some of the devices means only one device is going to be controls the entire operation, right? So that is going to be over here. So as you can see this, the red color thing is showing that it is a what is that, 8-bit data bus. This is the 8-bit data bus which you are seeing on the screen. So this thing is called as a data bus. As I said, we are having the handshaking signals. These three signals are acting as a handshaking signals. So these three signals are called as a handshaking signals, which are DAV, NRFD, and DAC. Okay, now rest of 5 signals, these signals are acting as a bus management signals. So these 5 signals are acting as a bus management signals. So these are the signals which we are using in the IEEE 488 bus. Okay. So the next case is, let us go back to the explanation. So when you are trying to interface the signals, yeah, let me show you this one. I'm sending this PDF to you people, don't worry. So here we are having the 24 pin connector, and as I said, when you are trying to communicate the different devices to the system, so obviously we are going to have the what is that, a male connector as well as a female connector. So here here whatever the diagram which we are seeing right over here, they are the female, and we are having the male connectors also. Remember that when you are trying to communicate one device, connect one device to the this particular IEEE 488 bus, there are hookers, means just like the hookers means we are going to connect the device using the screws. Okay, now so in order to avoid the disconnection from the bus, the device is going to be connected to the bus using the screws, which you can, I think you would have observed that one in our RS-232 case. Means we prepared our microcontroller application in the system in the computer, and we dumped that one to the microcontroller kit using the RS-232 cable. So when you are trying to interface that RS-232 cable, I screwed up that particular cable to the microcontroller kit. I think all of you would have seen that particular one. I give the explanation for all the batches. So just recollect that information regarding this. Okay, now. So if you see this one, the total 24 lines are there. 24 lines are grouped into 4 categories. One is the what is that, data lines, bus management lines, handshake lines, and the ground lines. Okay. So this is a brief explanation about the IEEE 488 bus. But whatever the PDF which I am going to send you for IEEE 488 bus, it is only for realizing the concept. Not don't write this one in the exam, because the exam scenario, in the exam scenario they are following the standard textbooks, not the information like this. Okay, now it is only for realizing the concept. It is not for writing this information in the exam. If you want, you can differentiate. If you want, you can write some of the points in the exam, but don't use the complete. Don't use this document as a material for your IEEE 488 bus. You are supposed to go to your standard textbook, which you are seeing on the screen, right? So this is a standard text from the textbook. We are having the IEEE 488 bus, right? So this is the IEEE 488 bus. So okay, so IEEE 488 bus, which bus topic which I sent you. But when you are going for this particular IEEE 488 bus, we are supposed to consider some parameters like the cable which we are using to construct this particular IEEE 488 bus should have the low inductance characteristics, as well as should have the low resistance. Otherwise there is a chance of inducing the noises again, in terms of the inducing the noises again, because when you are sending the information using this particular bus now, at that time there are the possibility of means the signal which we are sending using this particular bus is a binary zeros and ones. But this information is going to be transferred very fast now. When it is transferred very fast through the bus, then there is a fast through the bus, means we are having the binary 1, binary 0. Binary 1 is nothing but a high pass, binary 0 is nothing but the low pass. So when there is a transition from the high to low pass, low to high pass, what will happen? This particular transition may becoming the noise when it is transferring, when the transition is done very fastly, high to low, low to high. There is a possibility of involving the introducing the noise into the communication path. If at all the communication path is not the good characteristics one, means it should have the whatever the path, whatever the cable which we are using for the IEEE 488 bus, this particular cable should have the low inductance property as well as the low resistance. Okay, now so that is the main intention of that is the main what characteristics point which you are supposed to remember when you are designing the, or when you are using one cable for designing the IEEE 488 standard. Okay now. So this is what we're having. Another case is we can interface when we are trying to interface that one device with another. As we know that the device is accepting the information in one format, means in just like the TTL, input signal levels are one format, output signal levels are going to be the other format. Okay now. So the input signal format are one way, and other output signal format are going to be the other way. Okay now. So here what I'm doing is I'm having the different drivers, the line drivers. We are calling the line drivers for connecting the devices. Well, some of them are called as a open collectors, and some of them are called as a three-state drives. So we are having the open collector drivers as well as the three-state drivers. Depending on the type of the driver, the input characteristics means the input voltage range and the current range, and the output voltage and the current range. They are going to be changes from one driver to another driver. Okay, now from one driver to another driver. But when you are trying to send the some of the signals like NRFD, ND, AC, SRO signals, these signals are using the open drain, which is open drain case, and which is nothing but the right over here it is the open collector, right? We are using the open collector case. Okay now. So this kind of what connecting properties are going to be used in constructing the IEEE 488 bus. So if you see this one, wait. So using this particular screen recorder is playing a big drawback to me. Okay, okay, no problem. Yeah. So here, as I said, when we are having the common bus, obviously there is a what is that? Voltage differences among the bus among the devices. The ground voltage is going to be different, so that is going to be takes a means that is going to be takes the advantage. The voltage difference takes the advantage to involve the noise into the system. So to overcome that one, as I said, we are having the what is that Smith trigger as well as the that what do we say that diode is going to be used to avoid the negative voltages which are going to be damage the receivers. To protect that one, we are using the we are using the Smith trigger along with the diodes. So open collector we have seen, as well as this is going to be the three-state buffer acting as a what is that the drivers. So it is acting as the input as well as the output. We can disable the output terminal depending on the data transmission. They are acting as the inputs as well as the outputs, but when the line is acting as the input line, the signal characteristics are going to be changed, just like the TTL family, just like the TTL case. So input lines means 0 to 0.8 volts are treated as a binary 0, 2 to 5 volts are treated as a binary 1 in case of the input case. If the same lines are acting as output lines, at that time binary 0 is going 0 to 0.4 volts are acting as a binary 0, 2.4 to 5 volts are acting as a binary 1. Okay, now just like that, when we are having the different drivers, the input characteristics and output characteristics with respect to the signals are going to be changes. So that is a point which you are supposed to remember when you are go through the IEEE 488 bus. Okay, so I think we covered all the points which are related to the IEEE 488 bus. The main intention of the IEEE 488 bus is to communicate the devices using the parallel communication, but the advantage of this one is we can communicate 15 devices at a time. We can communicate 15 devices at a time, which you are seeing on the screen. So 15 devices, even though 15 devices are able to connect, only one device is going to be the transmitter and other devices should act as a receiver. One more point is, if you are trying to communicate, let us suppose I am taking one example. Yeah, this is an important point which you are supposed to remember when you are going through the IEEE 488 bus. So here, this point. So these are the handshaking signals. Now handshaking signals are nothing but before exchanging the actual data, these signals should get exchanged between the devices to establish the communication. I'm just rounding on this particular screen. If you see on the screen, so these three handshaking signals should get exchange between the devices before sending the actual data, before receiving the actual data. For example, in our communication, we are using the 15 devices, means 15 devices are communicating. One device is acting as a transmitter, which in this terminology, which we call it as a talker, who is talking, who is sending, and the rest of the 14 devices are acting as a listeners. Okay, let us suppose if any one of the listener is not enabled this signal, NRFD signal, then definitely the communication is not going to be stopped, which means how many number of devices are participating in the are connected on that particular bus, except one device who is sending, the rest of the devices should get ready. If any one of this device is not ready for receiving the data, it is going to disable this particular NRFD signal. It is going to be disables this particular NRFD signal. Means out of 14, if one device is disabling this particular signal, then the communication is not going to be stopped. So that is a major point you are supposed to remember, which is going to be explained at the end of this particular one, description part of our IEEE 488 bus case. So this part is going to be explained that one. So if any one of the out of 14 devices, if any one of the devices is disabling the NRFD signal, then definitely the signal, the communication is not going to start. So means after all the devices are going to be ready, at that time only the transmitter is going to be sends the information. You just remember that point. Okay, now so data valid means the master is going to be place the data on the data bus and generates a DAV signal indicating that data is valid, and this signal is going to be used by the slaves to indicate their readiness, and this signal is going to be used by the slaves again to indicate that we received the data. This is for a transmitter. These two signals for used by the receivers. One for showing the what is that, their readiness, and another for showing that whether they accepted the data or not, they read the data available on the bus or not. So these two are used by the slaves, and this one is used by the master. So you can go through this particular material for realization process. But when you are going for explanation in the exam, you should go through the standard textbook about this particular IEEE 488 bus. It is only for realizing the concept, because this is a simple way of explanation about the IEEE 488 bus. But this one is going to be a little bit confused, which is explaining the characteristics. You can get the same thing when you are going through this particular document. I'm going to send this particular document in the WhatsApp group. Don't worry about this one. So another case is, yeah, with this the IEEE 488 bus is over. So if you see this one, let us see the thing on the screen. So this is the third unit which we are covering right now, and except the DC AC servo motors, we already seen the stepper motor case in the classroom. In the classroom only for the for what? Yeah, for the lab session. During the lab session, I explained the stepper motor. Same concept we are going to see that one. So as I already explained the stepper motor, I'm not going to touch that one right now. Later I'm going to explain. I'll make a video on this particular stepper motor. Don't worry about it. But about the DC and AC motors, I need the standard textbook, because the mathematical derivation part is not good. If I'm going through the internet material, which is not going to satisfy us, we are going to get the better explanation through the internet about the AC and DC servo motors, where we are using those scenarios, means a brief explanation about the servo motors is available in the net, but we can't use that information in the exam, because there is a mathematical derivation part which is related to the DC and AC servo motors, so which is not there right now with me. So I'll explain that. I'll make a video on that one once the lockdown is over. I'll make a video, and I'll put it in my YouTube channel. I'll let you know, no problem at all, about the DC and AC servo motors. Don't worry, we have the YouTube channel right now, so at any time we can make the video, and I can send the video on this particular, I can upload the video on this particular YouTube channel, and I'll give the link, no problem at all. Don't worry about the DC and AC servo motors, the mathematical part, all those things. Okay, so with this, except the motors, I think all the topics are covered in the third unit. Okay, so let us review the third unit once. Open loop control system means control system is nothing but some electronic devices are arranged in such a way that which is going to be use the controlled outputs, controlled outputs. Control outputs means they are performing certain operations. Either it may be the open loop or closed loop, but they are performing some operations. Okay, now, so depending on the controlling operation, there are two types of control systems: so open loop control system and the closed loop control system. Open loop control system means here the user or the person who is using the open loop control system, manually they are supposed to switch on switch off the system. Okay now, closed loop control system means we are going to use the feedback element that one takes the responsibility to close the turn on and turn off the system depending on the present status of the present output status of the system. Based on that, it is going to take the responsibility to turn on and turn off the system. So in the block diagram explanation of the closed loop system, we have seen the transfer function. So the transfer function is nothing but Laplace transformation by the Laplace transformation of output by Laplace transformation of input with all initial conditions equals to the 0, or otherwise Laplace transformation of impulse response of a control system is nothing but the transfer function of that particular control system. Okay, so this is what we have seen, and I gave the explanation what the advantages and disadvantages of the closed loop transfer function, which we discussed in the first video. And if you want, you can go through my YouTube channel again to review that one. So after that, we started the analog and data acquisition system. Data acquisition systems are nothing but they are measuring the information and storing the information for future use, and depending on the type data, means how the data is going to be saved, whether in the analog or digital format. There are two types of analog digital data acquisition systems. So as I explained in the last class only, so this is what the analog and data acquisition system. So in the analog and data acquisition system, we are storing the information in the analog format as well as in the digital format. So after that, we are having the digital to analog multiplexer. If you want to send the information using the analog communication, if you want to send the digital data using the analog communication, we are using the digital to analog multiplexers, and analog to digital multiplexers are going to be the vice versa to this one, and IEEE 488 bus is going to be this one. So if you want, you can see, I think with this the third unit is over except the motors. I'll make a video on this particular motors later, not now. So after that, yeah, we have the temperature control. Yeah, I forgot to say one thing, that don't think that whatever the concept which we have seen for the temperature control and the liquid level, it is only for our bathroom and all those things. See, the explanation is in order to give the simple explanation, what they have considered is maintaining the temperature of a bath, or maintaining the temperature of a liquid available in the tub which is placed in the bath. It is not like that. It is only for the explanation of, they took the bath explanation, but this one, the temperature control as well as the liquid level controllers, are going to be used in the what we say the industrial purpose. They are the big devices, big devices which are going to be used, and which are used in the industry. Actually, these applications, whatever the simple application, simple topics which we have seen in the temperature control and liquid level control in the third unit, those are going to be the applications in the industry. Okay, now don't think that it is only the maintaining the temperature of a particular liquid stored in the particular water available in the bucket. Don't think like that. Here we are using the bucket, but there we are going to use, they are going to use in the industry, they are going to use the big tanks. Means we are interested to boil some liquid at 100, boil certain liquid liquid to at 100 degrees and 100 degree Celsius temperature. So is it possible to the human being to go and check it out whether it is reached to the 100 degrees Celsius or not? It is not possible. That's why they are using the sensors. Using this, with the help of the sensor, they are going to boil that particular liquid which is there in the container. After that, they are going to send that one to the further process. So that is a scenario. Don't think that it is only the simple one. As actually the temperature control and the liquid level control, whatever the topics which we covered in the third unit, actually not only in the third unit, in this entire paper, most of the topics are related to the industry. Most of the topics are related to the industry, but the simple explanation we consider only the small applications. Okay, now just remember that liquid level means when you would like to maintain the liquid flow and stored in a particular container. It is also not possible to the human being to check it out that how much liquid is stored in a container. Okay, now so there again we are going to use the liquid level control concept. Don't think that only it is a case of maintaining the water level in the tank, water level in the tank, just like our houses. Okay, now but it is not like that. But the same concept is going to be applied in the industry also. Just remember that one. So after that, we are having the transducers, all those things. We have seen the explanation of transducers and digital to analog, analog to digital, and triple E 488 bus. I think all of you realized the third unit. If you are having any queries, you can post the queries in the WhatsApp group. So I think I'm done with the third unit except the motors. Okay. And I'll send the what is that? I'll go to the fourth unit of this particular paper in the next coming classes. Okay. Thank you. If you are having any doubts, again I'm saying, if you are having any doubts, just let me know in the WhatsApp group. Thank you.